you want the event to be a memorial one, so you budget 30,000 per year forever. You see the keywords, right? Forever. So when it says forever, it means perpetuity. Guys, in the exam, there are a lot of different questions. You have to be able to read the question and analyze it and to figure out which one is suitable for you to use, okay? So try to analyze the content. It says last forever, so it gives you a hint. You should use the formula for perpetuity, okay? If the university earns 8% per year on its investment, that's your discounted factor or interest rate, that's R. And this 30,000, it will be your PMT, right? And if the first party is 1 year's time, so after 1 year, that's your assumption, right? Pre-assumption. How much would you need to donate to endow the party? Okay, so basically, you can draw a timeline. It says last forever, right? And then 1, 2, 3, n plus 1, last forever. And each period that you will endow 30,000. And then this 30,000 lasts forever. So what's the question? You know, now a lot of a trust is doing that. Or even like the scholarship you are receiving at NTPU, okay? One of the foundation actually donated a huge amount of a lump sum today. And then from next year, it can last forever, okay? So basically, we are computing the present value, how much is the lump sum today, okay? And then in order to be able to pay out from next year and last forever, okay? So basically, the question wants us to figure out the present value of the perpetuity. Okay? Now let's take a look. The timeline of the cash flows I've already drawn for you, right? And then you want to pay attention, the assumptions always start from end the first year and then last forever. So you know that PV of perpetuity equals to PMT over R or C over R, right? And then C equals to 30,000, R equals to 8%. Okay, so if you are able to figure out this some variables, okay, you can apply into the formula. PV of perpetuity would equals to C over R, 30,000 minus 0.08. So this is the total amount of money you should donate today to be able to get 30,000 payment for the rest of the years and last forever. Okay, 375,000. That's the PV of the perpetuity. Are we okay so far? Yeah? Okay, now the following is another cash flow stream which is regular as well, but it will end some points. Perpetuity means last forever. Annuity means it will end some periods, okay? So annuity is a regular cash flow, C bar, okay? Again, that should be the theme. Happens at the regular interval for a finite number of n periods. So it will end at n periods. And obviously, you would have if you take a look at the table, we have two tables related to annuity, right? One is FVOA, This stands for future value of an annuity. And one is PVOA. This is the present value of an annuity. So we are checking two tables. One is for future value, one is for present value. Okay? Guys, pay attention to here. This part is most difficult today. Okay? And it will appear next week in your exam. Right? First of all, you have ordinary annuity. Okay, all the formula and the tables, the table you are checking, and the formula I'm just gonna demonstrate to, I'm teaching you now, demonstrate it to you now. Formula and the table are applying to the ordinary annuity, okay? So this is formula and table are all referring to ordinary annuity. Okay. The second type of annuity is what we call annuity due. This means your first payment happened at time 0. Annuity due does not apply on our table, neither our formula. We have to figure out the value of ordinary first and then multiply by 1 plus 1 to figure out the value of annuity due. Okay, the most important is the ordinary annuity. If the question doesn't specify, then you assume it's all referred to this one, the ordinary annuity, because it fits the feature of financial instruments, okay? Here, ordinary annuity means the first payment occurs at the end of the first period. You really have to remember this assumption, okay? So if you look at this timeline as below, you see your first payment is here. Did you notice? There's nothing at time 0, right? So basically, this is referring to an ordinary annuity timeline. This is an ordinary annuity, okay? Pay attention. So again, if every period you have a C cash flow, and then it lasts until n periods, then we are able to computing its present value, right? So here at the bottom, present value of an annuity, can you also specify this is referring to ordinary annuity? The first payment happened in the end of the first period. Okay? So annuity, very basic computation. We just learned. You can consider it's like a stream of regular cash flow. So if you want to compute it, all these cash flows present value, just simply discard it each period's cash flow present value and sum them up together, right? This you already know. Agree? Each period's present value add up together. You can figure out the present value of annuity. Okay? However, if they are regular, they are all the same, then we can come up with the formula. We can also come up with table checking. So for the annuity, you remember you have 3 ways of a calculation. This is the first way. You just do it periods by periods. But it really takes time. We learned this already, right? So what I'm gonna do now, I wanna teach you how to check the table and how to apply the formula. Okay, we're gonna derive a formula for annuity now. Okay, if you guys are ready, we will start. Again, your annuity table have 2, right? One is future value, one is present value. So the formula we come up will have 2 formulas as well. One for future value of an annuity, one for present value of an annuity. Okay, but remember, these 2 formulas, they are all applied to the ordinary annuity. Are we okay with that? And finally, I will tell you, if the question tells you that this is an annuity due, how do we modify your formula? Okay? So if there's no problem, let's get started. Okay? So now, future value of an ordinary annuity. This in your tables called FVOA or FVIOA. Did you find this table here? You're gonna use that table next week, guys. Did you find this table? Yeah? Okay, if that's alright, first of all, let's take a look of the cash flow stream. 1, 2, 3, n minus 1. Oh, I'm sorry, minus 1, 2, 4. Because we have n periods, okay? So here, n, and then n minus 1. Okay, each period you have a fixed payment. Let's say C. This is an ordinary cash flows for the ordinary perpetuity, right? And remember, your first payment happened in the end of first periods. Okay, so remember, first payment occurs at the end of first period. Okay? And let's give a symbol for your interest rate. Okay, so interest rate equals to R. Okay, now we're gonna compute it FVOA, future value of annuity. Guys, we started with FVOA, okay? So, future value is here. You are computing future value of annuity first, okay? The first payment would be C. That's your n periods, right? Plus C times 1 plus R. This is your n minus 1 periods, okay? Plus And then in the end, C times 1 plus R to the power of n minus 2, your very first payment, C times 1 plus R to the power of n minus 1. Agree? The first payment compounded to the n periods. How many periods you're compounding? N minus 1. Agree? This is the first payment. So write it down. This is your second payment. This is your first payment. Can you guys follow me? Sum them up together is your future value of annuity. Okay, guys, can you write 1 here? That's your first formula. This is your first formula, okay? Second formula, let's do both right-hand side and left-hand side using the FVOA multiplied by 1 plus R. Okay? So what would happen? Don't forget your left-hand side needs to multiply 1 plus R too. And then the first payment becomes C times 1 plus R plus C 1 plus R power of 2, C 1 plus R power of 3, and then n minus 1 periods becomes C 1 plus R, and the final one will be C 1 plus R. I'm sorry, this is n minus 2, and then n minus 1. Here is minus 2, okay? So n minus 2. So here is n minus 1, and then finally n. Are we okay with that? Each period you multiply by 1 plus R. Each period's cash flows you multiply by n 1 plus R. Okay? So originally here is C times 1 plus R to the power of n minus 2. Now plus 1, right? Because you multiply one more time 1 plus R. So it becomes C times 1 plus R to the power of n minus 1. And the last period becomes C times 1 plus R to the power of n. Agree? Because it's n minus 1 plus 1, right? Can you guys follow me? Okay? Now, the third steps. Using 2 minus 1. So, the 2 minus 1, it becomes FVOA 1 plus R minus 1, right? Equals to, you pay attention, all these are crossed out. The only remaining would be your very last payment and very first payment. So equals to C 1 plus R to the power of n minus C. And then it becomes, you take the C out, 1 plus R to the power of n minus 1. Okay, and your left-hand side becomes FVOA times R, because 1 crossed out, equals to C 1 plus R to the power of n minus 1. And finally, because we want to figure out the formula for your FVOA only, okay? So left the FVOA in your left-hand side. We move this R to the right-hand side, okay? Final formula will become C over R, 1 plus R to the power of n minus 1. That's it. You have to remember this formula, okay? This formula is the formula for future value of an annuity. future value of annuity. This is the formula. Okay so far? Yeah, remember this one. And now, the following, we are able to compute the present value of annuity from this formula. It should be very straightforward, because this formula already sum up all the cash flow. Is one payment only. So if you want to figure out the present value, just simply discard it back by n periods, okay? So the following, we figure out FVOA equals to C over R, 1 plus R to the power of n minus 1, right? And then you know the PVOA would be, this is a multiplier you can leave outside. Inside, all discounted back by 1 plus R to the power of n, right? Present value equals to future value discounted back by 1 plus R to the power of n. Agree? We just went through this, guys. Present value equals to future value divided by 1 plus R to the power of n, right? So very straightforward. Present value equals to the future value, because it's multiplier. You can keep it outside, and then divided by 1 plus R to the power of n, these two terms, right? And then simplify it. These two terms cross out, right? So it becomes C over R, 1 minus 1 over 1 plus R to the power of n. Guys, remember these two. These two are the second way of computing the future value of annuity and the present value of annuity, okay? This is what we call formula. But remember, this two is the formula for ordinary annuity. Ordinary annuity means that the first payment occurs at the end of first period. Okay, remember this two formula. Okay, the third way is table checking. Guys, here, checking tables, okay? So, write it down. FVOA would equals to payment times FVOIA R% and period equals to C, payment would be your constant cash flow each period, times FVIOA or OIA, future value of annuity interest, okay? R% and periods. Likewise for your PVOA, PVOA would equals to PMT times FVOIA R% and periods equals to C times FVOIA R% and period. Again, this table, all the factors are referred to ordinary annuity. very, very important, yeah? So now you know that if there is a question related to annuity, you have 3 ways you can compute. The first way is this. You're doing it one by one. Okay? Here I can write up the future value here because I'm deriving both for you, so we can write up the FV here. FV would equals to C plus C times 1 plus R, 1 power of 1, and C 1 plus R power of 2, and then C 1 plus R power of n minus 1. That's your future value of annuity. So it will equals to summation T equals to 1 to n, C times 1 plus R to the power of n should be minus 1. Okay? Very important. The first method, and then the second method is the formula. The third method is table checking. Okay? So we have to remember this. Let's come back to this definition. Annuity is a series of equal dollar payment. So here you write down, this is your PMT equals to C bar. For a specific number of periods, that's the N, right? Ordinary annuity occurs at the end of each period. So that means the first payment happens at the end of first period. If you draw a timeline, 1, 2, 3, n minus 1, n. It will start it at 1. And then it lasts until the end. Okay? Now, I'm drawing you here below for annuity due for you. It's n periods. Start from 0. Okay? Annuity due start from 0 and ends n minus 1. So you really have to pay attention to the differences in these two cash flows. Okay? Annuity, ordinary annuity start from 1, end from n. Annuity due start from 0, ends at n minus 1. That's their different. Okay, you really have to pay attention to here. So, if you take a look at these two cash flows, you will figure out actually when you're computing the future value or present value, annuity due would always compounding one more periods compared with ordinary annuities. Okay? So now finally, I'm writing the annuity due formula for you. Okay? First, well, you can use the formula as well. FVOA, but this time is annuity due. Would equals to C over R, 1 plus R to the power of N.